This lesson deals with supplemental problem 4.1. You can find this problem in the ECE302 ebook in the Chapter 4 Supplemental Problems on page 1. In this supplemental problem, we're going to take a look at a 2N5486 N-channel JFET, and you can find the data sheet for this in the Motorola Semiconductor Data Library, Volume 2 of Discrete Products, Series A, on page 2-176. Let me pull up that page. This is giving me the specs of several transistors. See that there's some differences between them. Here's where their maximum ratings are, independent of the part number. And then some electrical characteristics. Now, sometimes in a data sheet, things are called differently than we did in the lecture notes, so you have to kind of interpret the data sheet and try to find the information. We're looking for the pinch-off voltage, and they're calling this the off voltage for the gate to source when the transistor is cut off. And they're giving a range for the 2N5486 from 2 volts minimum to 6 volts maximum. This turns out this is our pinch-off voltage. It's shown as a positive number, but in our modeling we're having a negative number. We could take the average of these two since we don't have a typical value but a range of values. The average of this would be 6 plus 2, which is 8, divided by 2 is 4. The pinch-off on the average would be minus 4. Here's the current I sub DSS, and it's saying it's from 8 milliamps to 20 milliamps. Again, we're looking for an average or a typical value, so we could add these two together and divide by 2, and that would give us 14 milliamps. And that's what I have back on the beginning of this problem. Pinch off, and then the value of IDSS. Assume that we're in saturation. What value of the gate source is needed to have a drain current of 4 milliamps? Then a different problem, if the gate source is minus 1 and the drain source is 1, could you find I sub D? And then lastly, if the gate source is minus 1 and the drain source is 5, could you find I sub D? All of our formulas have the term K in it, so let's find that. That's IDSS over the pinch-off squared. And we said that IDSS on the average was 14 milliamps and that the pinch-off was minus 4. We'll square that, and the ratio of those two is 875 microamps per volt squared. Here we have amps and here we have volts squared. Also shown here the N-channel JFET with the drain, gate, and source labeled, and then the gate source voltage, the drain source voltage, and the gate to drain voltage, and the drain current. If we're in the saturation region, or sometimes called current saturation region, we had a formula back in the class notes in chapter 4, and that's that the drain current was K times the quantity gate source minus pinch-off squared. Now we're trying to determine the gate source voltage that would give us a drain current of 4 milliamps, so we know that. The value of K we just calculated is 875 microamps per volt squared. The pinch-off is minus 4. We have everything but the gate source voltage. Let's divide by this. Take the square root of both sides of the equation, so we'll get the gate source plus 4. When we take a square root, you have a plus and minus root. Solving for the gate source voltage, we'll have two possible answers. So we're going to bring 4 over here. Minus 4 minus 2.138 is minus 6.138. And then minus 4 plus 2.138 is a minus 1.862. Now since the pinch-off voltage is minus 4, here we have something that's less than the pinch-off voltage, so that would put us in cutoffs. This is a contradiction, so this must be the value of the gate source voltage that would give us 4 milliamps of current in the current saturation or saturation region. In problem B, we had that the gate source was minus 1 and the drain source was equal to 1. Calculate the gate to drain voltage. It's going to be, go around the loop here, gate to drain is the gate source minus the drain source. It's going to be minus 1 minus a plus 1 or minus 2. But minus 2 is greater than minus 4, so we're greater than pinch-off. And our gate source is also greater than pinch-off because it's equal to minus 1 and pinch-off is minus 4. We're in the ohmic region. And in our chapter 4 class notes, we had an equation for the current in the drain when you're in the ohmic region. And that's K times the quantity 2 times the quantity gate source minus pinch-off times the drain source minus the drain source squared. This is 875 micro. Here's my 2. Gate source is minus 1. The pinch-off is minus 4. Drain source is equal to 1. And then we're going to square the drain source of 1 volt. That turned out to be 4.375 milliamps. And lastly, in part C, we had that the gate source was equal to minus 1, but now the drain source was 5. Our gate to drain is gate source minus the drain source. Minus 1 minus a plus 5 is minus 6. But minus 6 is less than minus 4, or less than pinch-off. And our gate to source is equal to minus 1, which is greater than minus 4. We're in the current saturation region, or just a saturation region like we were in part A. And we have the same equation for the drain current. We have a value of K of 875 micro. The gate source is -1 and the pinch off is -4. That gives us 7.875 milliamps. And this is higher than this case because our gate to source voltage is actually larger than this value here. So this makes sense. And this is supplemental problem 4.1.